Hi everyone, so we'll kick it off there. So thank you all for joining. It's great to see so many of you here with us today. So yes, thank you for joining on today's Ports webinar on the topic of our famous burp scanner. So before we start, we'll just do a couple of intros from our side. So I'm Hannah O'Malley, I'm part of the enterprise advocacy team here at Portswigger. So my role is to ensure you're receiving the necessary help and support and determine whether our tools are the right fit for your requirements. Alex, do you want to say hello?
Yeah, hi, I'm Alex Borshik. I'm the technical product manager on Burp Scanner. I look after this amazing bunch of scanner developers that work on the team, and I'm responsible for planning and delivering all the new features. I'll hand over to Dave.
Hi, I'm Dave. I work on the Burp Scanner. I've been a developer at Portswigger for about 3.5 years, and I've been working on the scanner the whole time, largely focusing on the crawler. And we have Tom.
Yep, hi, I'm Tom. I joined Portswigger 5 years ago now, but I moved on to the scanner team again about 3.5 years ago, and I've also mainly focused on the crawler in that time.
Great. We do also have a great team in the background running the Q&A box. That's located on the Zoom toolbar. So that also includes a few members of our Burp Scanner team. So if you do have any questions, please drop them in there. We will try and answer them as quickly as possible, but if we do miss any, don't worry, as we will be following up afterwards with anything we may have missed. So just to recap why we're here today and some of the exciting things we're going to cover. So Alex over here will be talking to you today about the Burp Scanner ecosystem, in which he'll be walking you through the history of Burp Scanner and how it's been innovated and developed over time. Dave will be showcasing some best practices, tips and tricks to help you get the maximum value out of Burp Scanner. Then Tom will be giving us an insight into what goes under the hood with Burp Scanner to showcase just how unique and complex it really is. And finally, we'll be giving you an exclusive sneak peek into our roadmap. And this includes some powerful and exciting upcoming features. And as I mentioned, any questions throughout this session, please drop them in the Q&A box. Keep the team very busy. That'll make us happy. And with that in mind, I'll hand us over to Alex.
Hi everyone. First of all, a massive thank you for everyone to take your time out here today to attend this. It's a real privilege to us to have you here today, and I really hope you find the session insightful and educational. So first of all, I'm going to walk you through some of the cool stuff we've been doing over the past few years. As many of you are probably aware, the Burp tool has been around for over 20 years. The first release of our Spider tool was back in 2004. I can't believe it's been so long, to be honest. So over the last decade, we've invested really heavily in the scanner, and I'm going to give you an overview of some of the cool stuff things we're most proud of. So back in 2015, we released our OS tool, which is called Burp Collaborator. I'm sure you're all aware of it. This was a game changer, really, when it comes to detecting out-of-band vulnerabilities. It's still incredibly powerful today. A lot of people have copied us. So around the same time, we realized that actually the old Spider tool it wasn't really fit for purpose with the modern web. It was easily confused by things like single-use tokens and stateful behavior. So we set about designing and building the new crawler with the goal of being able to fully find the attack surface of anything on the modern web. So the first version of the crawler that was released back in 2018 alongside our enterprise product. So the next sort of major milestone was when we released browser-powered scanning. Tom will talk a bit more about this later, but essentially we're letting the Chromium-based browser do the hard work of rendering and navigating around your target site as we're scanning. This enabled us to implement a load of really cool JavaScript features that just wouldn't have been possible without this browser integration. So some of the cool things we've done, such as recorded logins, that wouldn't have been possible without. DOM Evader, again, awesome, incredibly powerful tool to detect client-side vulnerabilities. Audit async traffic, and Dave's going to talk about some of this later. Instrumented crawler and prototype pollution scanning. These are all, a lot of these wouldn't have been possible without the browser-based integration. So some of the stuff we've been, nothing slowed down over the last 12 months. We're a very busy team. So at the start of last year, we thought, this crawler's cool, why don't we just give it away for free? So we released a free product called Dastardly. Now this is a free version of the crawler and scanner designed for use in your CI/CD pipelines, aimed at developers really. It's got a cut down seven important issues that developers find useful during the development lifecycle, intended to run in 10 minutes in your CI/CD pipelines, and dispel the myth that Dast is too slow for CI/CD work. We've totally revamped our extension API. This allows us to kind of continue adding more features so we can continue to develop the products. Talking a little bit later about live crawl views, but that's a really cool feature. Yeah, and some of the stuff we've got coming up in 2023, again, I'll talk about that a bit later on, but none of this would have been possible without the incredible team we've got here. I'm sure like, a lot of you are aware of James and Gareth, some of the awesome research that those guys do. I think James dreams in HTTP and Gareth dreams in JavaScript. They're a different level. We've also got Ben Smith. He's our cloud security researcher. He's busy at the minute working on our enterprise SaaS offering just to make sure that is secure and awesome. And we've also got an incredible team of really talented developers. I'm actually like incredibly privileged to have the Scanner team. We've got 9 developers on the team at the minute. We're continuing to invest and grow. We've been formed as a team for about 7 years, and it's a really good team to work on. So very proud of them. So some of the stuff in the ecosystem, everyone's hopefully familiar with the App Store. This is our curated list of extensions. If the product doesn't do what you want out of the box, the extension API lets many people do that. If you've not seen the Web Security Academy, again, this is like an incredible resource to go and learn about security vulnerabilities. It's completely free. It's got a load of online learning materials, online labs. You can go in there, log in, play with real vulnerabilities in a real life web app and learn all about security. I've already briefly mentioned Montoya, and we'll talk about B-checks, which is a new feature we're going to add very soon. So with that said, I'm going to hand over to Dave, who's going to walk you through some best practices when setting up your scans.
Thanks, Alex.
Hi everyone. So yeah, as Alex mentioned, I'm going to talk a little bit about ways to configure the crawler and scanner to get the best out of it. So I put a couple of quotes on the screen to start. These are from some fairly influential people here at Portswigger. James and Daff, very influential here. And really what these quotes are there to emphasize is that from the ground up, the scanner was designed to work with, not instead of, a manual tester. So it's really designed to alert you to behavior that is worthy of further investigation, whilst automatically finding everything that it can. It should help to take some of the tedium out of the recon process. However, over many years of developing the crawler and the scanner, we've added lots and lots of settings and tuning options. And we always try and pick sensible default values that will work for as many people as possible. However, in some circumstances, you might find that these options aren't getting the best for you. So I'm going to head over to Burp Suite, and I'm going to start a new scan. The first thing you have to do when starting a new scan is configure your seed, or sometimes referred to as start URLs, in your scope. There's quite often been a lot of confusion about these things, but as a general rule, a seed or a start URL is where you want the crawler to begin from, and the scope is where you want to allow it to go. So if I wanted to start a scan of Portswigger's Gin and Juice Shop, I would start by setting that as my seed URL, and then that's also applied in scope. It's worth mentioning that scope rules are considered to be prefixes, which means that when we're testing to see whether a URL is in scope or not, it has to start with exactly this prefix. If, for instance, your site redirects to another subdomain or a www prefix or a different protocol, for instance, HTTP to HTTPS, you may need to include those things in scope in order for the scan to start. If you need more fine-grained scope control, you can use advanced scope control to give you control over host, port, and individual files on the same server, and you can use regular expressions to achieve much more powerful rules there. So moving on to the scan configs, the first thing that you see when you go to the configs is our 4 preset configurations. We released these last year with the intention of providing generic out-the-box configurations that should work for a variety of scenarios. However, we're talking about the more interesting configurations today, so let's dive straight over to custom configs. So in the crawl config, the first thing I'm going to talk about is crawl using provided logins only. By default, BERT crawler will first try to navigate around an application without applying any authentication at all. And then it will apply the authentication later once it thinks it's explored all of the unauthenticated content. However, this might be wasting time. If your site is just a login form and then a bunch of interesting content beyond that, then you can use this option to skip the unauthenticated side of the crawl. If you're using a recorded login in the application logins, then the crawl will just start by running that login directly, and then it'll start crawling from whatever it finds. And if you're using a username and password-based authentication, then the crawl will run until we find a login form, and then it'll use the credentials as soon as we find that. So under crawl strategies, we have a really wide range of crawl strategies. In the fastest crawl strategy, we apply something we call Incy-Wincy mode. This is a really fast way of crawling around a site that is stateless. It's just super quick. It behaves a lot more like BERT's old Spider used to. So it just keeps a track of things that it has to visit and keeps going until there's nothing left for it to visit. It doesn't remember how it found any of the content, and it won't try and walk any paths. You can also use this mode to seed BERT crawler with cookies from the cookie jar. So if you authenticate manually using the proxy browser and obtain a session cookie, you can start a crawl already authenticated. You may have to set your logout URLs out of scope though, so that we don't accidentally log ourselves out. We do have a full YouTube video explaining Incy-Wincy mode that Tom has presented, and the link for that will be in the chat. On the other end of the scale, we have the most complete crawl strategy. As the name suggests, this really aims to explore as much of the application as possible at the expense of speed. And some of the ways it does that are waiting longer for client-side rendering. It'll submit forms with more values, and it'll be much stricter when we're trying to identify whether we're in a location that we've previously been to. At the other end of this menu, we have miscellaneous crawler options. By default, the crawler attempts to behave as much like a real person as possible. So it doesn't attempt to do any fuzzing. It'll only click links that it discovers naturally by inspecting the DOM. However, there are two really useful resources that we can use in the crawl, and those are robots text and sitemap. They can give us clues as to URLs that may exist on the site that aren't otherwise linked from. Likewise, if you have links that aren't rendered in the DOM, for instance, they come over in the response, but they're HTML comments or they're hidden away in JavaScript. Without this setting on, we won't necessarily find those links. We also have a Web Security Academy lab that demonstrates this vulnerability. Underneath this, we have application uses fragments for routing. Now, this is an optimization for single-page applications that use fragments on the client side as a way of representing the location. Many React applications often use the fragment as a way of representing where you actually are. BERT crawler used to ignore fragments altogether, since they actually don't exist in HTTP messages. They're never sent to the server. But they can be a useful identifier for where you are. However, the default behavior of BERT crawler is to attempt to infer whether the application uses fragments for routing, so don't worry if you don't know. We do have a reference guide for optimizing the crawl for single-page applications, and the link will be posted in the chat. Underneath that, we have the options relating to BERT browser. As Alex alluded to, putting the browser behind the crawl was really a game changer in terms of the capability of the crawler. It's incredibly powerful. It allows us to render responses, load and execute scripts, trigger XHR and fetch requests, and discover and interact with non-standard HTML elements that have click handlers on them. However, in some circumstances, you might not need it. If your application is built with traditional HTML elements such as anchors and forms and doesn't rely on client-side JavaScript rendering, then your crawl might be faster if you just turn the browser off, and it'll also use fewer resources because we're not using a browser in the background. Underneath this, we have the fetch required resources and data from out-of-scope hosts. Modern applications often use CDNs or other means for serving static resources. It's a really fast way of serving resources all across the world. Some sites will also fetch API data from separate subdomains or even entirely different hosts. Since the resources and the API calls are often required for us to be able to use the site properly, using this setting allows BERT crawler to temporarily ignore scope rules when fetching resources and data from APIs. However, anything we fetch during the crawl won't be sent to the audit. If you want anything to be sent to the audit, then you have to include it in scope. Finally, for the crawl config, we have a few hidden crawler options that are possibly useful in certain circumstances to achieve greater coverage. The first is click all clickable elements. And by default, the browser can tell us everything on it in the DOM that has a click handler attached to it. However, because this feature is a bit experimental at the moment, we have a strict allow list of things that we'll attempt to click on, and that's fairly traditional HTML elements like anchors and forms. Enabling this option will force Burp Crawler to try and click on everything that has a click handler on, whether it's a span, a div, any HTML tag that has a click handler, we'll try and click it. This may lead to greater coverage, and if it does, then please let us know, because we'd love to turn this on for everyone. The second option is idle time for mutations. In general, knowing that a page has finished loading is an incredibly hard problem. It might be impossible to know that a page has finished loading because it might actually never finish. You could have client-side scripts that are constantly making requests and adding more content to the DOM. As a general rule, Burp Crawler will apply this timeout to say how long to wait after a page navigation has occurred for client-side rendering to take place. If you increase this option, you might find that we discover more content on the site. However, it does come at a cost. This timeout is applied after every burp action, so you might find that your crawl suddenly takes a lot longer. We recommend playing around with this setting to try and find the balance between coverage and speed. And the final option I'm going to talk about from this menu is the await navigation timeout. After every action that is performed by Burp Crawler, we assume that things might happen. We click on a button, the page might change, the page might navigate entirely, or nothing could happen. We need an upper bound to wait so that we're not sitting around forever if nothing actually happens when we click on something, particularly if we're trying to click on everything that has a click handler on it. This timeout represents how long we will wait before assuming that nothing is going to happen. As with the previous option, if you increase this, you may notice that the crawls take a lot longer, so play around, find the right balance. So that's the crawl config covered. Now I'm going to talk a few settings in the audit config. And the first one is automatically maintain session. This is an incredibly powerful option and one of the real innovations that we brought with Burp2 Crawler and Crawl and Audits. Tom's going to go over a little bit more of the detail about what actually goes on here. But in short, we ensure that all the payloads we send during the audit are received by the application in session. We obtain any single-use tokens and cookies if we're required to, and we'll even check the session is still valid before committing issues to reduce the number of false positives. If you right-click items in the sitemap and send them to the audit, you don't get the benefits of this, so we really recommend using crawls and audits. The second section of config we're going to talk about is handling application errors. Like any tool that uses the internet, Burp Scanner is susceptible to temporary network issues. Anytime a request fails, we will move on from the current scan check. It might just be that the single request failed. If we get 2 consecutive failed requests for the same insertion point, then we assume that the insertion point might not be suitable for us to be attacking. For instance, we could be attacking a session cookie and inadvertently logging ourselves out. If we have 2 consecutive failed insertion points, then we skip all the remaining insertion points for the item because the item itself might not be suitable for us to attack. And if you get 15 consecutive items failing in a row, then we'll just pause the task under the assumption that the whole site may be unresponsive at this time. It's worth mentioning that in Burp Suite Professional, this will show the task as paused in the dashboard, but in Burp Suite Enterprise, this will show as failed. We have an error reference guide for configuring the section that's going to be dropped in the chat. Once a audit phase has completed, and Tom's going to talk a little bit about what an audit phase is in his section soon, we'll complete another follow-up pass in which any failed requests, scan checks, insertion points from the previous phase will be retried. So although sometimes it might look like there's items with errors, allowing Burp to retry, you might see that those errors go away. Finally, on the topic of configurations, I'm just going to mention that configurations, when you apply multiple configurations to the same task, those configs are applied in order. And sometimes that can lead to unexpected side effects when multiple configurations both change the same setting. For instance, in this crawl I prepared earlier, I applied 2 configurations which both changed the user agent header. However, when you go and view the config that was actually used for the crawl, you can see that the second user agent was the one that was actually used. This is because the second configuration overwrote the value from the first one. It's really easy to get confused when applying multiple configurations to the same task. So our best practice for this is to generally use the fewer number of configs as you can get away with and try and change as much as possible in the same config. Now, hopefully, once you've got all that configured, then you can set your task away. One of the really cool things that we introduced this year, and Alex alluded to before, is the live crawl view. And this is a way in which you can see what the crawler is doing in real time. To view the live crawl view, click the view details pop-out and head to the live crawl view tab. Every time the browser that is performing the crawl is rendering a new image, it is sending that image over to Burp so you can see exactly what the crawler is doing. It's a really good way of seeing the crawler iterate through all of the content on the site. Another way in which you may discover what the crawler is doing is by using the target tab. The target tab will show all of the locations that have been found by the crawl. And usually this gives you a reasonable representation of what the crawler is finding. However, in some circumstances, you might find that it's not showing you very much, particularly in cases where you're scanning a single page application or the URL is the same for many locations. The first location that the crawler finds at any given URL is the one that goes in the sitemap. So sometimes you might think that the crawler is not doing much, but the location count is still going up. At the moment, you're just going to have to trust us that we are actually finding more content, but we are actively working on better ways to represent this information. And Alex is going to talk about that at the end of today's Swigonaut. So that concludes my section on today's Swigonaut. So I'm now going to hand over to Tom, who is going to talk a little bit about what is going on under the hood in Burp Scanner.
Thanks, Dave.
Thank you, Dave. Yep, so hi again, I'm Tom from the Burp Scanner development team. And yeah, today I'm going to talk a little about what's going on under the hood when you're running a scan in Burp Suite Pro or Enterprise. So I'm going to start off talking about the crawler mostly. And Burp's crawler's prime directive is to find unique and interesting content in a web application and the paths through that application that reliably reach those requests. The first part of this is kind of intuitive. So we want to audit all of the interesting content found in an application, and we don't want to waste time auditing content that represents the same attack surface. The second part, however, is a bit more interesting, and that's paths. I'm going to dive straight in with an example. So if I go to, this is just the proxy browser for Burp, I'm going to head over to Portswigger's Gin and Juice shop, which is our deliberately vulnerable web application. If I head over to the product, and I grab one here, so we can see if we have a look at this form here, that we have got a single-use CSRF token. So if I submit this form, yeah, we're going to get our single-use CSRF token submitted along with it. If we found this request in the crawl and then just started hammering it with payloads in the audit, like me repeating it here, so this is just the same request that I helpfully prepared earlier, so I didn't have to find it again. If I send this to repeater, go ahead and just send it with the same CSRF token, we're just going to get 400. So yeah, if we were just doing this in the audit, just hammering it with payloads, we just keep getting these 400s, and we wouldn't actually be testing the attack surface that this form represents. We'd just be effectively testing the CSRF validation, which isn't ideal. So what Burp Crawler does instead is it finds the path to this request and can rewalk it each time it wants to send a payload. So in this case, as I've demonstrated, the path would kind of be if we go back to the landing page, let's make this a little bit smaller. So we go to products, yep, we go to view details, and we submit our form. Now, because we've walked a full path, when we go to find this form and submit it, we've got a brand new CSRF token, it's fresh, it's valid, and when we send the payload, that would actually hit the attack surface that we're trying to test. Now, obviously this is pretty expensive, especially as we get deeper into the application. So we do try to simplify these paths when we send them to the audit. We'll try to find the shortest subpath that still reproduces the same location at the end. We can also dynamically adjust the length of this path as we go. So this example that I've just shown has got single-use CSRF token, so we do have to walk the full path every time. We need a new token every time we want to send a payload. But you can kind of imagine a scenario where the CSRF token is session-based. So as long as we are within session, we can keep using the same token, and that's absolutely fine. And in these cases, the audit can pick up on this and just keep sending the same base request over and over again, and it's all good. However, you can imagine maybe one of our payloads upsets the WAF that the application is using, and our session gets killed. Suddenly, that request isn't valid anymore. Now, what Burp Scanner will actually do is it will detect this. It will notice that the responses we're getting don't match what we saw during the crawl, don't match what we expect from the application. And it will realize that, oh, actually, I need to go back to walking the full path. I've trashed my session. I need to go and effectively rewalk the path and go and get another one and go and get another valid token and valid session. So while the audit's running, we're effectively optimizing and finding that a valid path that's as short as possible, but realizing when we need to kind of back off a bit and use a longer one. So cool Burp Scanner thing number 2 that I kind of wanted to talk about was browser-powered scanning. So using a browser to navigate the web these days is pretty much absolutely necessary. That's because websites are designed to be viewed in a browser, and a lot of the features they use only work in a browser. Feature number 1 is client-side rendering. This is where the DOM kind of isn't present in the over-the-wire HTTP messages sent by the server, but rather built client-side, often dynamically by JavaScript. So I'm going to head over to a second product in Gin and Juice Shop. Go to product number 5, which I happen to know has this behavior. If I go to the network tab, and I'm regretting making this smaller now, make it a bit bigger again. If we have a look at product number 5, and we have a look at the over-the-wire response for this page, this form up here just isn't present, and actually very little is present. And that's because this page uses React, it uses a front-end framework. The DOM is built client-side in the browser, and none of it comes back over the wire. So if we were just scraping this HTTP traffic for edges to crawl, we'd completely miss this. We'd look at this page, we'd look at this response, we'd go, oh, well, there's nothing here to crawl further, and we'd just stop. So instead, by rendering this, we can actually ask the browser what on the page is clickable. It will actually have the fully rendered DOM, and it can tell us about all the forms, all the anchors. And as Dave was saying earlier, if we've got all clickables turned on, it can tell us about all kinds of things that are clickable. It's not enough just to use a browser to render pages, though. You actually need to use it to interact with the edges that you find. And this is because JavaScript event handlers might be changing how elements behaved compared to how they would traditionally behave. So again, going back to this form, if we have a look at it, and this time we will have a look at it in the rendered DOM, let's just right click on it to jump to it. Have a look. So this one doesn't actually appear to have a CSRF token. However, when we submit it, and we head over to the network tab and we go and find the request for that and have a look at the payload, there was a CSRF token. Now this is because there's an on-submit event handler. When we submit the form, JavaScript is going and intercepting that event, and instead of doing the usual behavior, it's building its own request and sending that, and it's adding parameters that weren't present in the form originally. So by telling the browser to submit the form, we actually get the correct complete behavior of that element rather than kind of seeing the form. If we looked at the rendered DOM and saw this form and tried to build a request from it ourselves, knowing how forms work, we wouldn't include the CSRF token, and we'd go back to the failure case we had before where the server would just be giving us 400s and we wouldn't actually be hitting the attack surface. So then finally, we've got async traffic. This is all the requests that are required to put a page together. So gone are the days when a website would be built from static responses that are pretty much one request, one response per page, maybe a little bit of CSS to pretty it up a bit. Instead, we've got all these requests going on to put a page together. We've still got CSS, we've got JavaScript though, we've got JSON blobs, we've got XHR requests. Now, if we, sorry, go back to this one. If we had a look at the response and just tried to scrape out what requests might be required to build up the page, we might do a decent enough job. There are some links up here, we can see some of them. But it's much easier and much more accurate to just tell the browser to interact with the elements, tell it where to go, tell it what to click, tell it what to submit, and then keep an eye out and capture all the traffic that happens. This way we get an accurate view of what traffic is actually required, and we can send all this to be audited as actual correct requests. Again, the main point of this and the main point of all of these three benefits is that we're actually sending requests that behave as the application intended rather than trying to kind of second guess the browser page and probably get it wrong. So those 2 points were mainly crawl focused. So I'm going to put my audit hat on now and talk a little bit about some audit related things. So as Dave suggested, or as he alluded to, Burp Scanner has a multi-phase approach. So whether the audit is running after a crawl or you've selected items from the sitemap, each phase here, so we've got all of these phases, each one will run in its entirety for every single scan item before moving on to the next phase. And why will become apparent shortly. So I'm now just going to quickly go over what each phase does, starting with passive. Passive, we have 2 phases. In the first phase, we just look for any and all passive issues for all of our scan items. In the second phase, we start to consolidate these and then report them. The reason this is across 2 phases is that a lot of passive issues tend to be pervasive across the whole host and not just limited to a single item. So unencrypted communications, for example, if we imagine this was all on HTTP, we'd be finding unencrypted communications for every single scan item, and there's no point reporting it for all of these URLs. So instead, what Passive 2 does is it will go and join these all together and say, right, the host is vulnerable to unencrypted communications, not every single request. Oh, thank you, Bert. So next up, we've got the active phases. Active 1 is just all of our first order checks. So for every scan item, we'll run all of our first order scan checks. Active 2, we will then send a canary to every single insertion point in every single scan item. Then in Active 3, we'll reissue every single scan item and look for those canaries in responses. This is why the multi-phase approach is important, because by sending canaries to every single scan item and then looking for them in every single scan item's response, we can link any 2 arbitrary requests together and say that there's a stored data path between them. When we input data in one, it appears in another. After this has been done, after we've found our stored data paths, we can move on to Active 4, which is where we use, and this is where we do all of our second order checks, using the information from the previous 2 phases. In Active 5, we send a collaborator-based blind XSS payload to all of our insertion points. Finally, we've got the JavaScript phases. This has got 3 phases. Phase 1 finds self-contained static and dynamic JavaScript issues. Phase 2 finds reflected issues, and phase 3, which has a dependency on 2 and 3 from the active, finds our stored JavaScript issues. So that's all of the scan phases covered. So next up, I wanted to talk a bit about insertion points and some of the cool things the scanner does around them. Now, you can obviously send manually identified or defined insertion points to the scanner if you know precisely where you want your payloads to go. However, the scanner can automatically identify insertion points itself when it's either seeded with requests from the sitemap or from a crawl. Now, this automatic identification is encoding tolerant and supports nesting of types and encodings. So, for example, and bear with me here, this is a contrived example. If the crawler sent a request to be audited that had a base 64 encoded query parameter that's actually JSON when it's unencoded, Burp Scanner would be able to place payloads in the JSON object values and then re-encode everything back properly to how it was in the URL. Also, in the case that requests being audited came from the crawler, as I've already spoken about, because Burp is rewalking paths every time it sends a payload, the requests that might actually change between each scan check for a single scan item, because we're going in, as I said, getting fresh tokens, making sure the request is correct. So because these insertion points are moving, if we were just attacking hard-coded offsets, we're just placing our payloads in hard-coded places, we might start to miss those insertion points. So you can imagine cookies might change order, or an even simpler example would be if your CSRF token was the first parameter, actually, I think it was in here. Let's have a look. Yep, so our CSRF token is our first parameter there. If this changed length, then this term parameter is going to actually move slightly. Its offsets won't match anymore. So what Burp Scanner does is, instead of representing insertion points as just hard-coded offsets, it will actually understand information about the insertion points and be able to relocate them each time it sends a request and place the payloads in exactly the right place where the insertion points value should go. One final cool insertion point related feature is frequently occurring insertion points. However, in the interest of time, I'm not going to go into this right now. So instead, I'm going to plug our YouTube series Burp Suite Shorts. That's why I'm wearing this amazing t-shirt. I recorded a video on this feature actually earlier today, and that should be out tomorrow or Friday. So keep an eye out for that. Finally, from me at least, I just wanted to go over issue consolidation. So this is because one question we get asked quite a lot is, when I run a second scan of the same target, how come I didn't find any issues? Like where are the issues? You found them the first time, where are they? This happens because issues are stored at a project level, not at a task level. We treat projects as being the repository for information about a target, not tasks. So if and when a task runs and a scan check finds an issue that's already been reported for the same location, as a rule of thumb, we only keep the most interesting version. And that's kind of to say, if the second time around we found further evidence or increased our confidence or severity, we'll update the issue. But if it's just the same, then there's no point reporting it again. That's pretty much everything from me. So as you may have noticed, a lot of that was kind of an out product in Chrome demo of what's going on under the hood. This is because, as Alex and Dave both already alluded to, it's not always entirely obvious what's going on under the hood in Burp, and that's something we're working on right now, working on improving. So I'm going to pass it back to Alex, and he's going to talk about that, and as well as some other upcoming exciting things.
Cool, thank you very much, Tom. So yeah, I'm going to quickly talk about some of the things we're working on and some of the stuff hopefully we will get delivered this year. So as we mentioned before, we've been very busy working on single page application enhancements. This work is not done. It's been going on for years. It will probably continue for many more years. But some of the most important things we're going to release soon. We're going to release. Currently in modern web applications, you don't have to enclose input elements in a form within a form tag like you used to do traditionally. There was a bit of it's been an edge case in the crawler, we've not been able to deal with them. So that's, I think, the next early adopter release, which is going out next week. It should have support, much better coverage for form elements that are not really attached to a form. The other thing is, as Dave mentioned earlier, we really want to turn on the all clickable elements. We're busy testing that in a minute, and hopefully we'll have that turned on for everyone by default fairly soon. After that, so B checks, you may have noticed on the ecosystem before. So we're really quite proud of this one. It's been a lot of hard work. It turns out writing your own programming language is actually quite tricky. So the guys had a lovely Christmas thinking about this. So this is very nearly ready. So what are B checks? They enable programmers to quickly release new scan text. It's a simple text-based language. They aim to be easily shareable, easily readable by anyone kind of familiar with web security. The idea is that we're going to host a curated repository of them, so we can share them easily. As new vulnerabilities hit the internet, we can respond to them really quickly. And ultimately, at the minute, you have to wait. If we want a new scan check, we have to wait for the scanner team to actually build it and wait for a product release. You know, these things you can upload into Burp and have them there straight away. So these are quite exciting. Give you a quick example. This is what the language looks like. This is a SSRF scan check in the referrer header, so you can see there it's putting a collaborator payload into the referrer header and then asking if there's any interactions in the collaborator, then we'll report a high severity issue. This is very nearly ready to go. We're just doing some work on the UI just to tidy things up. A little bit more testing to go, but hopefully this will be out with you in the next couple of releases. Okay, the next thing that we've talked about quite a bit here is kind of actually exposing some of the magic that's going on under the hood. So the only real tool we've got at the minute is the target tab that just groups things by URLs. So these days, URLs don't necessarily mean much in a modern single page app. So this is a prototype, a very early prototype of what we're going to do to the target tab. So we're going to have a new tab a new sub tab on the target, so you can switch your target tab to either show you the traditional URL structure view, or you can show a new view that actually shows you the navigational paths that the crawler has walked through the application. So this is the sequence of action that the crawler has taken. So you can see here it navigating around the site, it's clicking on blogs. It'll show you when it's playing recorded logins, things like that. So we're quite excited about this. It's a large piece of work, so it's going to take a while for us to deliver this to you. Hopefully, we will be drip feeding small features to you over the rest of the summer. But we're very excited about this one. Another thing we're about to pick up imminently, we're going to do some GraphQL specific scan checks. So we will detect whether an endpoint is GraphQL. We will use introspection and suggestions API to introspect the APIs and try and auto-generate payloads and GraphQL queries, and also do some scan checks looking for request CSRF bugs against GraphQL endpoints. That's quite exciting. Another thing that a lot of people have been asking us for, so at the minute, if you run a scan and we encounter a open API spec or Swagger definition on the that's hosted in your site, we will go away and we will generate a load of API requests from that Swagger definition. We often get asked, why can't I just give the API definition to the scanner? So we will be doing that over the summer, and hopefully get that feature to you to both this and enterprise. Okay, and that's all we've got for you today. So thank you very much. Thanks to Tom. Thanks to Hannah. Thanks to Dave. It's been awesome.
Yeah, great work, guys. And first of all, thank you so much for all the questions. I'm really glad you guys took it seriously when I said keep the Q&A team busy. I think they'll all feel a bit tired after that. So just before we go, we'd love to just get a bit of your feedback on these on the session so far. Let me just actually try and launch this poll. It's not letting me. Hopefully one of the Q&A team can be able to do that in the background. But we will be following up from this session to support you with any sort of help that you may need, any useful links and email addresses. And the Q&A team will be sticking behind for another 5 minutes to answer any more questions you guys may have. So please feel free to drop them in. And again, yes, thank you all so much for joining. We look forward to seeing you all again. So we'll just leave this open for you now so you can drop more questions. Bye, everyone.